So what is the oxidation number? The oxidation number is related to another concept of chemistry, the electronegativity. Electronegativity is a periodic trend and is the ability of capability of an atom in a molecule to attract bond electrons. So we can consider this molecule hydrochloric acid. The red electron is a hydrogen electron. The black electrons are chlorine electrons. Chlorine is much more possess a much more electronegativity than hydrogen. So it means that chlorine is able to attract the electron of hydrogen that goes closer to chlorine. So we can give this electron to chlorine. This is not true because the bond is a covalent bond. So this couple of electrons are shared between hydrogen and chlorine. But we pretend that the red electron, the hydrogen electron, is now a chlorine electron. So it means that the chlorine has one more electron that should have. So we can say that chlorine is -1. So this is the oxidation number for chlorine. And obviously hydrogen that lose his electron now is a +1. In a molecule, the molecule is electrical neutral. The sum of oxidation number must be 0, must be null.
Let's take another example, water molecule. In this case, the oxygen is the atom with a higher electronegativity. So we can donate the electrons of hydrogens to oxygen. So the oxygen, the oxidation number of oxygen will be -1 and hydrogen +1. And for the other bond, -1 and hydrogen +1. So the total oxidation number of oxygen is -2. The oxidation number of hydrogen is +1. In general, oxygen has -2 as oxidation number, and hydrogen +1 is if it's bonded to atom with a higher electronegativity. Oxygen has also other oxidation number, less common, such as -1 in peroxide compound, such as hydrogen peroxide, and also positive when it's bonded to fluorine, because fluorine has a the highest electronegativity of the element. This is the Lewis structure of hydrogen peroxide, and as we can see, the oxygen are bounded together. So in this case, the oxidation number are 0, because we cannot attribute the shared electron to either to the oxygen. So oxygen will be -1 compared to hydrogen, that is +1, because we can attribute the electron of hydrogen to oxygen, and we can make the same for the other bond. And so at the end oxygen will be -1 and hydrogen +1. The total oxidation number of molecule is still 0. Another example, in this case, so oxygen, the electronegativity of oxygen is higher than carbon, and oxygen makes with carbon 2 bonds. So we can attribute one of those electrons, the electron of carbon, to oxygen, and the same for the other couple, one of those electrons to the oxygen. So also in this case oxygen is -2 and carbon is +2. Now we can compare carbon to hydrogen. Carbon, the electronegativity of carbon is higher than hydrogen, so the electron of hydrogen, we give the electron of hydrogen to carbon, so the carbon becomes -1 and hydrogen +1, the same for the other bond. So if you make the sum of the oxidation number of carbon is 0. So we can calculate the oxidation number also from molecular formula. And hydrogen is bounded to carbon and oxygen, and both atoms have an electronegativity higher compared to hydrogen. So hydrogen must be +1. Oxygen, we know that generally is -2, because this is not a peroxide, there isn't fluorine in this molecule, so it's -2. So carbon should be a number that make 0 the sum of all oxidation number, because in the molecule the sum of all oxidation number must be 0. So +1 multiplied 2 is +2, -2, so the sum should be 0. So it means that also carbon should be 0.